The main idea behind this lesson is to place strength design by inelastic analysis in the broader context of connection design and make fundamental comparisons to traditional strength design. Many aspects of connection design are the same, whether using the traditional strength design approach or strength design by inelastic analysis, but there are key aspects that are different. The differences in those key aspects lead to different challenges, which are highlighted in the lesson. In simple terms, inelastic analysis recognizes that steel doesn't behave perfectly elastically all the way up to failure. It does this by explicitly modeling yielding, and importantly, efficient inelastic analysis enables the powerful method of connection design implemented in IDEA StatiCa. Inelastic behavior is important because it naturally occurs in real structural connections. Under load, steel connections begin to yield locally, redistribute forces, and continue carrying load beyond the initial yielding. Traditional design methods simplify this behavior into isolated checks and equations. This is practical and effective, but it doesn't always show the full picture of how the connection behaves. Understanding inelastic behavior helps engineers better evaluate strength, ductility, stiffness, reserve capacity, especially for complex or non-standard connections. Understanding the process of strength design by inelastic analysis, as well as its fundamental assumptions and common challenges, is a necessity for anyone using this method in practice. In traditional design, the engineer has to identify the load path. In fact, if the connection is statically indeterminate, then the engineer has to select the load path. This is not the case with design by inelastic analysis, where the load path naturally arises based on the modeled stiffness of the connection elements. Doing this first lesson, you should walk away with a basic ability to interpret key analysis outputs. The analysis outputs help you identify if you've modeled the connection correctly, if the behavior is what you expect, and if the connection is able to safely support the load. This is important for common connections and uncommon connections alike. You have to know your tools. If you're using inelastic analysis in practice, such as using IDEA StatiCa for connection design, it's really important to have an understanding of what the software is doing.